About monoclonal antibody. Now, mono means single. If you know that mono means single, clone means to make a similar copies. So, monoclonal means if prepare the antibody against the single epitope of the antigen, then the antibody are known as monoclonal antibody. Now, normally when we inject the antigen in your body, if you see, I have given here. It is a antigen with a multiple epitopes. These are known as epitopes. Now when you inject it into the body produce antibodies against all these epitopes, and so that time the antibody are known as polyclonal antibody. But if I isolate a single epitope, suppose I have isolated it, and when I inject the single epitope, the body produce antibody against the single epitope, and the antibody against the single epitope is known as monoclonal antibody. So the monoclonal antibody itself has wide range of application, which I will discuss later. Now first we have to discuss how the monoclonal antibody are produced. Now, monoclonal antibody production technology is otherwise known as hybridoma technology. Why it is known as hybridoma technology? Because the monoclonal antibody is produced in a cell which is a hybrid cells, which is known as hybrid cells. Now, as you know, hybrid means it is a combinations of two cells. Which of the two cells we have taken for hybridoma technology? We take plasma cells and we take myeloma cells. Now, what is the reason of taking plasma cells and myeloma cells? Now, when I discussed with you, I hope that you remember that I have told you that antibody basically produced by plasma cells. Now, B lymphocytes, I have told you the B lymphocytes after getting stimulation from T lymphocytes broken down into two cells or proliferate into two types of cells. One is known as memory cells and one is known as plasma cells. Now, memory cells keeps the copies of the antibody and plasma cells secrete the enormous quantity of the antibody. So, the antibody basically secreted in the circulation by plasma cells. Now, this is the rationality of taking plasma cells. But what are the disadvantages of the plasma cells? The plasma cells is short-lived. The lifespan of the plasma cell is short. That's why we combine the myeloma cells with the plasma cells. The myeloma cells is a cancerous cell line. Now, as you know, the cancerous cells line are immortal. So, if I combine the plasma cells with a myeloma cells, then the plasma cells produce enormous quantity of antibody, and plasma cells, the lifespan of the plasma cells can make indefinite, and lifespan can be increased as it has been fused with myeloma cells, because the myeloma cells is a cancerous cells. Now, that's why the monoclonal antibody are produced in this type of hybrid cells, that is hybrid of a plasma cells and myeloma cells. Now, there are different steps for production of monoclonal antibody. If you see in Satyanarayan, you will get all that production steps for the production of monoclonal antibody. I will discuss some key steps. Which need understanding. Now, first, if you produce monoclonal antibody, you have to isolate the antigen. More specifically, the antigen with a single epitope. Then you have to inject it into mice. Sometimes, for injection, we used antigen with adjuvant. As you know, adjuvant increases the immunological response of an antigen. It increases the antibody titer or immunological response of an antigen. So we take antigen mixed with adjuvant and inject into the mice. Then we collect the spleen. because spleen cells, splenocytes or spleens is a resource of lymphocytes. Is the resource of lymphocytes. From lymphocytes we isolate plasma cells. Next we do the hybridization of plasma cells and myeloma cells under the influence of polyethylene glycol, which is known as polyethylene glycol. It is otherwise known as crowding agent. Now what we do is we incubate the plasma cells with myeloma cells. Now when you incubate it, the three possibility, after the incubation, the three possibility will come. What are the possibility? Possibility is that we have incubated or we have fused the plasma cells with the myeloma cells. So there are three possibility of this experiment: unfused myeloma cells, unfused plasma cells, and fused myeloma cells and plasma cells, which is known as hybridoma cells. Now our target is to isolate the hybridoma cells from this mixture of cell population, that is mixture of cell population made up of unfused plasma cells, unfused myeloma cells and fused cells. For that we used HAT medium. Now if you see, now HAT medium, full form of HAT is, HAT means HAT. H stand for hypoxanthine, A stand for aminopterin, T stand for thymidine, Now if you recall, which is most of the case for you people is very difficult because your minds are very volatile. Now if you recall the synthesis of purine and pyrimidine why the cells become immortal? Because they synthesize their genetic material. Now genetic material means they synthesize their DNA for indefinite period of time, and DNA is made up of bases, that is purine and pyrimidine bases. Now if you see the synthesis, if you recall the pathway for synthesis of purine and pyrimidine bases, you will see there are two pathways for purine and pyrimidine biosynthesis. One is salvage pathway and one is known as de novo pathway. And another one is known as de novo pathway. Now first you see the de novo pathway. Now de novo pathway starts with dihydrofolate. One of the precursor for de novo pathway is dihydrofolate. The dihydrofolate with the enzyme which is known as THFR. Full form of that enzyme is tetra. T stand for tetra, H stand for hydro, tetrahydro, F stand for folate, R stand for reductase. The full form of the enzyme is tetrahydrofolate reductase, converted into THF, that means the DHF means dihydro is converted into tetrahydrofolate. It is by a reduction reaction, and this reaction is performed by dihydrofolate reductase enzyme. DHF has been converted into THF. Now this THF gives rise to production of different purine and pyrimidine bases. This is the basic of de novo pathway. Now if you see the salvage pathway, salvage pathway starts with hypoxanthine. Now hypoxanthine, with the help of an enzyme, you see that enzyme HGPRT. What is the full form of HGPRT? The full form of HGPRT, you listen carefully. The full form of HGPRT is hypoxanthine. H stand for hypoxanthine, P stand for phosphoribosyl, or you can say phosphoribosyl, RIBOSYL, phosphoribosyl. T stand for transferrin. it is HGPRT, means H stand for hypoxanthine, G stand for guanosine, hypoxanthine guanosine phosphoribosyl transferase, converted into IMP and GMP, which ultimately give rise to production of different deoxy bases of DNA, that is DATP, deoxyadenosine triphosphate, deoxyguanosine triphosphate, deoxycytosine triphosphate. And another, this is all about HAT medium. In HAT medium we have told that it is full form of HAT is hypoxanthine, aminopterin and thymidine. Now thymidine, with the help of an enzyme in salvage pathway, thymidine kinase, converted into DTTP, or full form is deoxythymine triphosphate. In that way, the salvage pathway give rise to synthesis of different bases of nucleotides, or you can say different bases of DNA. Now, interesting fact is that we have told two pathways, one is salvage pathway and one is de novo pathway. Now, the de novo pathway is active only in myeloma cells, whereas the salvage pathway is active in plasma cells as well as in hybridoma cells, So in a HAT medium, we used hypoxanthine, aminopterin and thymidine. Aminopterin acts as a inhibitor of dihydrofolate reductase. Dihydrofolate reductase means it blocks the de novo pathway in myeloma cells, because dihydrofolate reductase is the enzyme which convert dihydrofolate into tetrahydrofolate, and tetrahydrofolate gives rise to production of different bases. So if you block this enzyme, that is dihydrofolate reductase enzyme, by aminopterin, so that dihydrofolate cannot convert it into tetrahydrofolate, and as the tetrahydrofolate is not forming, it will not give the production of different nucleotides. So in that way we block the nucleic acid biosynthesis in myeloma cells in HAT medium. So if we screen in a HAT medium, it is as if you do the screening in HAT medium, as these myeloma cells cannot synthesize their nucleotide, they will die because they cannot synthesize their nucleotides. The remaining cells, what are the remaining? We have remaining two cells, that is plasma cells, unfused plasma cells and hybridoma cells. So unfused plasma cells and hybridoma cells, among them our target is hybridoma cells. Now as already I have told you, the plasma cells have short lifespan. So after some time, you can say some generation of subculture, the plasma cells will automatically die because of their short lifespan. So what will remain is hybridoma cells. In that way, HAT medium is utilized for the screening of the hybridoma cells, because hybridoma cells are the key for the production of monoclonal antibody. You have to isolate hybridoma cells. That means if I tell again, what will happen? I have incubated plasma cells with hybridoma cells. We get three possibilities. What are those possibilities? When you incubate it, three possibilities will come: unfused myeloma cells, unfused plasma cells and hybridoma cells. And we do the screening in HAT medium. HAT medium contain aminopterin, which block this de novo pathway, so myeloma cells will die. Which will remain will be plasma cells and hybridoma cells. The plasma cells will automatically die because of their short lifespan, so you can isolate these hybridoma cells. Now once the screening is confirmed then the hybridoma cells are grow in a large scale by a fermentation technology. You can do the way we produce the insulin and all, the hybridoma cells are cultured, from their antibodies are isolated, then they are screened against the antigen against which they have produced, and in that way the process will, you will get a detailed procedure, detailed method of procedure in Sottonar. All is right in whatever in written in the book. The important part is that the screening, which you will not understand if I not tell you how the screening has been done. That's why I explained this screening method. And next is, now these next important part is the applications of monoclonal antibody. Now monoclonal antibody nowadays are wide applications. Basically they are used to screen the disease cells. Or you can say they are used to produce or develop targeted drug delivery. What do you mean by targeted drug delivery? Now targeted drug delivery, there are other applications are there. You will, if you read it, you will understand. But some special applications of this monoclonal antibody are targeted drug delivery. Now what do you mean by targeted drug delivery? Suppose you consider cancer. Now cancerous cells, when you apply the normal chemotherapy, what will happen? As we know, the chemotherapy is toxic against normal cell also, not only against cancerous cell. It is toxic against normal cells also. So in conventional chemotherapy, what will happen? If you provide the conventional chemotherapy to cancerous patient, ultimately the cancerous patients will die because of the toxicity of this chemotherapy in the normal cells. So if we direct this chemotherapy to specifically to the cancer cell, I want to direct so that it will not harm the normal cells. What I can do? I will see that it happen, there are some antigens which are specifically expressed by the cancerous cell. There are some antigens which are specifically expressed by the antigen. So what I do is I will prepare a drug delivery vehicle. Suppose I prepare a nanoparticle. And in the surface of the nanoparticle, I will attach the antibody which specifically attached with the antigen expressed by the cancerous cells. In that way, I can target or I can deliver the chemotherapeutic specifically into the cancerous cells. This is known as targeted drug delivery, or in other words, it is known as precision medicine. Nowadays, in biomedical field, the precision medicines are coming up in a huge manner so that we can tackle the disease more effectively. Not only in cancer, you can say it against other metabolic disorders, against neuronal disorders, you can use this monoclonal antibody. So this is about monoclonal antibody. I hopeful that you may understand, though it is not a normal conventional classroom teaching where you can see where the understanding will be much more easy. If you have any problem, please clarify doubt from me. Don't hesitate. Thank you very much.